We're asked to find the standard deviation of the ANT data, and we can see in the formula that how we find standard deviation is we take every data value, which is called x here, subtract the mean, x bar, which we already found in a previous example to be 38.1667, square that result, and then after we have all of those, we'll add them up. That's what the sum is. Finally, we'll divide by sample size minus 1 and take the square root. So you can see in this example, I have each of the data values, 19, 25, 36, 43, 47, 59, subtracting the mean and then squaring that. So these 6 numbers here are the deviations from the data values to the mean squared. We take those 6 numbers and we add them up. That is what the numerator is saying to do. That will add up to 1080.833. Finally, then in the formula, we divide by n minus 1. We had n of 6 because we have 6 data values, so we divide by 5, and then we take the square root. This gives us a standard deviation of 14.703. It is measuring distance of the data values from the mean. If you do not square in this formula, these values, and you would just simply take each value and subtract the mean and add them up, they happen to always add up to 0. So squaring allows us to keep always a positive result. So this final number for standard deviation will always be positive. Then we're asked if the standard deviation is a resistance statistic. And so, like in a previous example, what if that last value of 59 was actually 159? What would the standard deviation look like instead? When we did adjust it to 159 earlier, we got a different mean, which was 54.833. So now, if we're taking all of our data values and we're subtracting 54.833 and squaring, and we add all those up, we have the 6 values given down here at the bottom. They will total up to 13,580.83. Now, when we divide by 5 and take the square root, we'll get a standard deviation of 52.117. Notice that that is quite a bit larger than the standard deviation in part A. So the standard deviation is not resistant to outliers. If we have some extreme outlying values, we will get a higher standard deviation, as opposed to the IQR, which we saw was not affected by those kind of values.